I wanted to provide you with an answer key where I've worked through the problems for the midterm practice exam. So I'm just going to jump right in. And question 1 on the midterm practice exam says divide the following complex numbers. Enter your answer in the simplest form, a plus bi. So the question is negative 66 plus 27i divided by negative 6 minus 3i. If you'll recall, to divide complex numbers, we actually perform multiplication and we multiply by the conjugate of the denominator. Now, conjugate is a fancy math word that means opposite. So you have the same two partners, negative 6 and 3i, but it becomes plus because the original was negative. So you have the same two partners, negative 6 and 3i, and then it becomes a plus sign. You can think about it like you got to have a male and a female. And so then we perform the multiplication. We multiply the complex numbers in the numerator and we multiply the complex numbers in the denominator. And we use FOIL to do that. So negative 66 times negative 6, and you may want to use your calculator for that. So we get positive 396. Negative 66 times 3i would be negative 198i. 27i times 6 would be negative 162i. Watch your signs. And then 27i times 3i is going to be positive 8i squared, 81i squared. And then we multiply the denominator together. So negative 6 times negative 6 is 36. Negative 6 times positive 3i is negative 18i. Negative 3i times negative 6 is positive 18i. Negative 3i times positive 3i is negative 9i squared. So then I'm going to go back and I'm going to simplify what I can, and also at the same time remember that I squared is negative 1. That's one of the primary things you have to remember whenever you're dealing with complex numbers. So I would have 396, and I'm going to combine negative 198i and negative 162i. So we're going to add those together since we have the same signs. So that gives me negative 360i plus 81. And in place of I squared, I'm going to put negative 1. And we'll go back and do that math in just a minute. Then in the denominator, we have 36. Whoops, got a little messy there, sorry. Minus 18i plus 18i zeroes out, and I have minus 9, and then again I'm going to replace I squared with negative 1, and I'm going to go back and do that math. Okay, so we have 396 minus 360i minus 81. 81 times negative 1 is negative 81. And then I have in the denominator 36 plus 9. Minus 9 times minus 1 would give me positive 9. And then finally I've got to come back and at the last step combine those like terms again. Okay, so we would have 396 minus 81 gives us 315. Okay, so we combined the real parts. Minus 360i over 36 plus 9 is 45. And we may be able to simplify that if you break this apart, because it wants it written in that form, 315 over 45 plus, or excuse me, not plus, minus, watch your signs, don't make the mistake Miss Ralston made, minus 360 over 45. And we always want to try to simplify our fractions if possible. So if I simplify these fractions, 315 divided by 45 is 7, minus 360 divided by 45 is 8. So we end up with we end up with 7 minus 8i. Question number 2 gives you a function. It says the function d is defined as d of x equals negative 3x squared plus 2x plus 1, and it wants you to find d at 3. Guys, don't overthink it. This is a very straightforward problem. To find d at 3, you're simply going to plug and chug. You're going to plug the value 3 into the function wherever there is an x. So if I do that, I would have negative 3 times 3 squared plus 2 times 3 plus 1. Now you can get your calculator, but I'm going to work it out here in my head. So negative 3 times 3 squared is 9. Make sure you follow order of operations. Plus 2 times 3 is 6 plus 1. Negative 3 times 9 is negative 27 plus 6 plus 1. Do the math. Negative 27 plus 7, we're going to end up with negative 20. So D at 3 is negative 20. Okay, don't overthink it. Utilize the calculator if you need to. Okay, question 3 says determine the intervals for which the function is decreasing. Okay, it's important, make sure you read carefully that you're looking for the places where it's decreasing, which basically implies the graph appears to be going down, which it appears to be going down at this place and then also at this place. The other thing you have to remember is that whenever you're stating intervals, you should always state them from lowest to highest, and you accomplish that by reading your graph from left to right, and the intervals are always stated in terms of x. Okay, whenever you're stating intervals for increasing and decreasing, it's always stated in terms of the domain, which is x. So for decreasing, it appears to be going from negative infinity down to this point here, which has an x value of negative 2. So it goes from negative infinity to negative 2. And then we begin again when we get to an x value of 0, and we go to positive infinity. The arrows on the end again imply that you're going to infinity. Number 4, it's the same graph, but this question asks you to find where the function is increasing. Okay, so again, read carefully to make sure you get the right answer. So increasing, again, it looks like it's increasing on that particular interval. Again, you go lowest to highest, and you do it in terms of the x. So the x value at this point is 2, or negative 2, excuse me. And the x value at this point is 0. Notice that I am not including the endpoints. You do not include the endpoints when you are thinking about increasing and decreasing, because technically at that point, at that one particular instance, it's actually not moving. It's not increasing, nor is it decreasing. All right, number 5 ask you to identify the local minimum point. Again, it's important that you pay attention, the local minimum. So I hope in your mind when you see that word minimum that it clicks that you want the lowest. Okay, so if I'm looking at this graph, the lowest point appears to be this point here. And it says to write it as an ordered pair, and that point would be -1, 1. Okay, also it also reminds you to always write it in terms of x comma y. So the minimum point here is -1, 1. Again, a lot of it's going to be making sure you read the question carefully. Question 6 asks you to find the local maximum point. Okay, the maximum does imply the highest, and because it's local. Okay, so I hope that triggers in your mind that you're looking for the highest. So again, looking at that, really that same graph, the high point is this one, and it corresponds to the ordered pair -5, 6. Okay, double check yourself, -5, 6. Again, make sure you write your ordered pair in x comma y. Okay, pay attention. Guys, some of these questions are not intended to trip you up. They're really just as straightforward as they appear to be. All right, question 7 asks you to find the average rate of change for the given function on the interval 2 to 6. Okay, so ultimately for the average rate of change, which is delta x over delta y, it's similar to the slope. You have to do basically your y2 minus your y1 over x2 minus x1. But we don't have those ordered pairs initially, but we have the information to find them. In this interval, you want to go from 2, which would be your x1, to 6, which is your x squared, or your x sub 2, excuse me. And so this is really a 3-step problem. Okay, so step 1, we need to find f at 2. Okay, because that's our x1 value. So I'm going to substitute 2 into the given function. So I have -4 times 2 squared plus 4 times 2 plus 2. I'm going to do the math. -4 times 4 plus 8 plus 2. That gives me -16 plus 8 plus 2, which ultimately gets me to -8 plus 2, which is -6. So that I'm able to find the first ordered pair, which is 2 comma -6. So this is your x1, y1. Step 2 is I need to find f at 6. So I'm going to plug 6 into the given function. So I have -4 times 6 squared plus 4 times 6 plus 2. That equals -4 times 36 plus 24 plus 2. -4 times 36, again, you may want your calculator, is -144 plus 26, 24 plus 2. So -144 plus 26 is -118. So our second ordered pair is 6 comma -118. This would be our x2, y2. Now that we have our two ordered pairs, we substitute into the average rate of change formula Okay, so delta x delta y equals y2 negative 118 minus y1, which was negative 6. So that's really minus, and I'm going to write it out, negative 6 over x2, which is 6, minus x1. So I have negative 118 plus 6 over 4. Negative 118 plus 6 is negative 112 divided by 4. Negative 112 divided by 4 simplifies to negative 28. So the average rate of change between 2 and 6 for that given function is 28. But it's a three-step process. You are allowed scratch paper for the midterm exam, so you want to take your time and work it out, go step by step. Use your calculator as you need to. All right, question 8 is actually a multiple choice question, and it wants you to match the graph for f of x equals the opposite of the absolute value of x minus 3 plus 5. Now there's a couple of ways you can do this problem. If you want to think about it from the graphical perspective, which is probably the way you should since you're matching a graph, one is you can sketch the graph yourself using what you know about transformations and then match it. Okay, so with this graph, looking at what transformations are taking place, you remember you have the A is the number out front, B is in front of the X, C is inside, and D is outside. So the translations or the transformations for this graph is going to go up 5, right 3, and there's going to be a reflection or a flip on the x-axis. So, and it's a V shape because absolute value is a V shape, which normally starts at 0, 0. So we're going to go right 3, up 5, and then it's going to be flipped over. Now, I may not be exactly dead on, but at least I have a rough sketch, and you could at that point go over and scan the graphs that's given on in the practice exam. So it is not the first option. It doesn't appear to be the second. Looks like it might be the third. It looks like it is the third option. Now, the other thing you can do, if you're familiar with how to enter it into your calculator, is to use the calculator to create this graph and then match it up. So I'm going to show you how to do that. We would go to y equals, and let me clear out the one that I have in there. And we need the opposite, so we need negative. And then to get your absolute value, you go to math, arrow over to NUM or num. Option 1 is ABS, which stands for absolute value. Then we're going to do x minus 3, get out of the absolute value symbols, and then say plus 5. So that it basically looks exactly like what we have on our paper. And then I'm going to tell it to graph. And again, it gives you that visual that you can then go and match up. Number 9 says, given the function below, determine whether the function is 1-to-1. Okay, to be a 1-to-1 function, you can have no repeat in the y values. Now, just as a side note, as a review for you, since you're getting ready for the midterm, I hope that you remember that to be a function, there's no repeat in the x values. So I'm assuming, since it indicates in the question that this is a function and I can check it, there is no repeat in the x values. To be 1 to 1, there is no repeat in the y values. So if I'm looking at this particular function and trying to make that decision, I look and I see that there is a repeat in the y values for a value of x equals 6 as well as x equals 2, which tells me this is not a 1-to-1 function. Number 10 asks you to identify which of the graphs are 1-to-1. Okay, which of the graphs are 1-to-1, and it says select all correct answers. Guys, there's several questions like that where you may be able, or you should possibly check more than one correct answer. From a graphical perspective, we determine whether a function is 1-to-1 using the horizontal line test. Okay, basically, if a horizontal line crosses the graph only one time, then it is considered 1-to-1. If it crosses more than once, then it is not 1-to-1. So if I'm looking and thinking, and you can imagine drawing horizontal lines, the first option is 1-to-1. The second option is 1-to-1. And a lot of people think that sometimes when this thing that it levels out, but it actually never levels out to a perfectly horizontal line. So there's always a little bit of a curve to it. The third option is not 1-to-1, because if I draw a horizontal line, it crosses the graph 2 times. So this one is not 1-to-1. The fourth option, again, if you run the horizontal line, it crosses 2 times, and so it is not 1-to-1 either. Okay, so again, notice that in this particular problem there are 2 correct answers. That is acceptable because the instructions tell you to select all the correct answers. Number 11. With number 11, a lot of students sometimes confuse this notation. It's consistent with what you've seen in Newton, but this notation is a composition. Okay, with a composition, that means we're going to substitute x into function f, get the answer, and then substitute it into function g. It is not multiplication. Okay, which is what many students confuse it with. So be careful, pay attention to those notations. All right, so if we begin, this is kind of a process. Again, you can think about it as a process. We're going to start with x, and we're going to plug x into function f. Okay, that's this piece right here. So if I plug x into function f, I get 6x minus 4. I'm then going to take that answer and I'm going to substitute it into function g. Okay, so I'm going to plug 6x minus 4 into function g wherever there is an x. So I would have, and I'm going to try to color code this for you, we would have 2 times the x squared plus 5. Well, the x is 6x, whoops, I didn't get my purple, is 6x minus 4. Okay, so then I got to do some math. So I've got to square this binomial. So we have 2 times, and remember to square that, that is literally 6x minus 4 times 6x minus 4. Using full, I have 36x squared minus 24x minus 24x plus 16, and then I still have the plus 5 outside. From there, you can do a couple of things. You can either simplify first or distribute the 2. I probably would simplify first. So I have 36x squared minus 48x plus 16, and then the plus 5. And then I'm going back to distribute the 2. Okay, so if I distribute the 2, I would have 72x squared minus 96x plus 32 plus 5. And finally, I'm going to come back and combine like terms. I have 72x squared minus 96x plus 37. That is G composed with F at X. Okay, number 12 is a similar problem, but it wants you to find and simplify F minus G at 3. So again, it's a 3-step problem really, because you have to first find F at 3, which would be 3 squared, which is 9. Step 2 is to find G at 3. So we would have the opposite of 3 plus 4, which is 1. And then finally, we want to find F minus G. So F at 3 was 9. G at 3 was 1, and we want to subtract. 9 minus 1 is 8. That would be your final answer. All right, 13. 13 asks you to find the inverse of the following one-to-one function. Okay, it does tell you that it's one-to-one, so you don't have to worry about that. Again, this is a process. Step 1 in finding the inverse is I'm going to interchange x and y. So I'm going to rewrite this problem as x equals the opposite of 3 times the square root of y plus 2 minus 6. Okay. Then the second step is to solve that equation for y. So the first thing I need to do would be to add 6 because I'm trying to isolate the y. So I have x plus 6 equals negative 3 times the square root of y plus 2. I would then, because I'm trying to isolate the y, at that point I'm going to divide both sides by negative 3. So I have x plus 6 divided by negative 3 equals the square root of y plus 2. Keeping in mind your goal to get y by itself, I need to eliminate the square root. So I'm going to square both sides. So I have x plus 6 squared over negative 3 squared is positive 9 equals y plus 2. And finally, the last step, because remember I'm trying to isolate the y, my last step is going to be to subtract 2. So that I end up with x plus 6 squared over 9 minus 2 equals y. And that is actually the inverse of the function. So this is f inverse of x. This is the answer. At number 14, ask you to find the vertex of the parabola. Hopefully you recognize that, one, it's a parabola because it has a squared term. Two, that form that it's given in is the vertex form. And when you're in the vertex form, you're in the form x minus h squared plus k, and the vertex corresponds to your h and k. You just have to be careful and watch the signs. The h is 3 and the k is 2. Okay, notice that it's minus and minus, so you use the number that's there. Okay, because it really would read the opposite of h. So it's 3. So my vertex is 3, comma 2. Number 15 gives you a graph, and again, it's important that you read the question carefully. It says determine the x-intercepts of the parabola, and it also tells you you could have more than one answer. Looking at the graph, the x-intercepts occur where the graph crosses the x-axis. So it crosses at this point, which is -5, 0, and it crosses at this point, which is 2, 0. So my x-intercepts are -5, 0 and 2, 0. Question 16 says to find all the real and imaginary zeros of the following polynomial by factoring and or the quadratic formula. So one thing that you might need to know here is how many are you looking for? Okay, well remember that your degree, which is the highest exponent, equals the number of zeros. So I notice that my highest exponent is 6, so I should have, when I'm done, 6 zeros. Furthermore, in looking at the polynomial itself, I realize that I have a common factor, so I'm going to use factoring. So I have a common factor of x squared, and so then I have x to the 4th minus 7x squared minus 8. And that actually, we're have it set equal to 0 because we're trying to find the zeros and solve for x. So I have x squared, and then I'm going to try to break down x to the 4th minus 7x squared minus 8. So x to the 4th would be x squared times x squared. I need a pair of numbers that will multiply to 8 and subtract to 7. I believe I can use 8 and 1, and it's a -8 and a +1, and that's equal to 0. Once I have it completely factored, and it is currently completely factored, then I have to set each one of those pieces to 0. So x squared could be 0, or x squared minus 8 could be 0, or x squared plus 1 could be 0. And I'm going to solve each of those respectively for x. To undo a square, hopefully we remember that we need to take the square root. And when you take the square root, it could be plus or minus. So we have plus or minus 0, which actually means you have a multiplicity of 2 at 0. Your 0 is 0 and it occurs 2 times. Solving x squared minus 8, we're going to add 8 to either side. So we have x squared equals 8. Then we're going to square root both sides. So we have x equals plus or minus 2 on the square root of 2. Okay, it's always plus or minus when you take the square root, and we need to simplify the square root of 8, which is 4 times 2, which becomes 2 on the square root of 2. Finally, x squared plus 1, we're going to subtract 1 from either side. We have x squared equals negative 1. Again, to get rid of the square, we're going to square root each side. So we square root. Again, it could be plus or minus. So we have x squared. And by definition, excuse me, we have x, not x squared. We have x equals the square root of negative 1. And by definition, the square root of negative 1 is I. So we have plus or minus I. Knowing that we should have 6 answers, we have plus I minus I plus 2 square root 2 minus 2 square root 2. That's 4 answers. And then the 0 occurs twice because technically it's plus 0 and minus 0. So I do have 6 answers. So your answers are 0 with a multiplicity of 2, plus and minus 2 square root 2, and plus or minus I. Okay, number 17 says use the graph to determine, to find the domain of the function. Okay, so domain, what you have to remember here is that domain corresponds to the x values. You also have to pay attention to your graph and realize that arrows imply that the graph continues on forever and ever in the direction that the arrow is pointed. And so in this case, it appears it's going to continue going on and on the left as well as the right. So the domain is going to be all real numbers from negative infinity to positive infinity. There doesn't appear to be any holes or any gaps, so we can use all the numbers on the x-axis between negative infinity and positive infinity. Okay, this is, I believe, question 20. I forgot to number it. It's question 18, excuse me, I forgot to number it. Question 18, and it says, which of the following are even functions? Okay, so you have to remember, and again, it's important that you pay attention, what does it mean to be even? And also notice that the question says select all that apply. So you could have more than one. To be even means that your graph is symmetric to the y-axis. Now you can do it visually or you can do it algebraically. Probably visually would be the easiest, at least to start with, and then you could verify algebraically. So if I go over and I use the first one, negative x plus 2, I'm going to clear out the graph I have. I'm going to go to y, and I'm going to do negative x plus 2, and I'm going to graph. Okay, so that gives me a line, and so then I have to think about it. If I fold this graph across the y-axis, which is the vertical, would the graph be on top of itself? And I surmise that it does not, so this one is not 1 to 1. Then I want to look at x squared minus 5. Takes a little time, but it's okay. Y equals x squared minus 5. And we want a graph. Now, to me, that one does look as if it is symmetric to the y-axis. And so I'm thinking maybe so, and I can verify that algebraically. I'm going to substitute negative x into the function. So I have negative x squared minus 5, which gives me x squared minus 5. Notice it comes out to be the same thing that I started with, which verifies for me that this particular function is even. But now, guys, you can't assume that just because it has a square that it's automatically even. Okay, so don't just go down through there checking the other ones. So then the third one, go back and check. We have negative x squared, and I forgot the rest of it, minus x minus 4. Whoops, excuse me. Minus x minus 4. Okay, and we're going to graph. Now, when I look at that one, it looks like it's a little bit off. It doesn't look like it's centered. But if I want, again, to verify that, I can substitute negative x into the problem and see if it comes out to be the same. So if I check this third one, I would have f of negative x is the opposite of negative x squared minus x, or minus negative x minus 4. So this would give me the opposite of x squared plus x minus 4. Notice it's not the same, okay? So that one is not even, which is what we saw visually. Okay, the fourth one, x plus 4. Okay, so we have x plus 4. Again, it's a line, so thinking about whether or not it would fold on top of itself, I don't believe it does. So I'm pretty confident on that one. So x plus 4 is not even. And then if we check negative x squared plus 2, again, I realize this is taking some time, but this is probably the easiest way to do it. So negative x squared plus 2, and we graph. Again, that one to me, it looks like it's symmetric to the y-axis, that I could fold it in half and I couldn't tell it the left from the right. So if I check that one, I'm going to have f at negative x equals the opposite of negative x squared plus 2. So I have the opposite of x squared plus 2. Notice it does also come out to be the same as the original. So the second and the fifth one are even functions. They are symmetric to the y-axis. All right, 19 ask you to determine the horizontal asymptote. Okay, again, it's important that you pay attention and note that you're looking for the horizontal asymptote. To find the horizontal asymptote of a rational function, you have to compare the degree of the numerator to the degree of the denominator. Now the degree is the highest exponent on the variable. So looking at this function in the numerator, we have the value of 1. There's no variable. So the degree of the numerator is 0. For the denominator, the degree is 1. So comparing them, 0 compared to 1, 0 is less than 1, so the numerator is less than the denominator. The rule says when the degree of the numerator is less than the degree of the denominator, there is a horizontal asymptote at y equals 0, the horizontal axis. Now, so that's the answer for this particular problem, but so that you know the guidelines for the others as well, if the numerator is equal to the denominator, there's a horizontal asymptote at the ratio of the leading coefficients. You'd have the leading coefficient of the numerator divided by the leading coefficient of the denominator. If the numerator is greater than the denominator, there's no horizontal asymptote. Okay, so those are the three guidelines. The one that applies here is this first one. So we do have a horizontal asymptote, and the horizontal asymptote occurs at y equals 0. Okay, question 20 says find all the intercepts, both x and y, of the function. And again, it's multiple choice, and it asks you to select all the answers that apply. So you're not only looking for the x-intercepts, you're also looking for the y-intercept. It really doesn't matter which one you do first. Okay, to find the y-intercept, we let x equals 0 and we solve. So if we do that, we have 0 squared plus 7 times 0 minus 18 over 0 plus 3. So I'd have 0 plus 0 minus 18 over 0 plus 3 is 3. So I have negative 18 divided by 3, which is negative 6. So written as an ordered pair, my y-intercept is 0, negative 6. To find the x-intercepts of the rational function, you let y equals 0 and solve for x. But the shortcut is you take just the numerator. We're not concerned about the denominator. We take the numerator and we set it equal to 0 and we solve, either by factoring or using quadratic formula. Again, it seems that this one will factor, so I'm going to use factoring. 9 times 2 is 18, and 9 minus 2 is 7. I need a plus 9 and a minus 2. And then I know that one of those equations, either x plus 9 was equal to 0 or x minus 2 is equal to 0. And we solve each of those respectively for x. So I'm going to subtract 9 and I get x equals negative 9. Then the other one I'm going to add 2, so I have x equals 2. So written as ordered pairs, my x-intercepts are negative 9, 0 and positive 2, 0. So you would actually select 3 answers because you have the y-intercept and 2 x-intercepts, which is a total of 3. Again, guys, it's important that you pay attention to the instructions. Okay, question 21 says find the inverse of the following 1-to-1 function. It again tells you initially that it is 1-to-1. We did one similar to this earlier. Okay, and so remember the process is we interchange x and y. So we would have x equals 5y plus 3. And then we want to solve for y. So initially I'm going to subtract 3 from every side, or from both sides, excuse me. X minus 3 equals 5y. My goal being to get the y by itself. I'm then going to divide by 5, divide by 5. So y equals x minus 3 divided by 5, which represents F inverse. 22 is a similar problem. It tells you you have a one-to-one function, and it asks you to find the inverse of that one-to-one function. So again, we begin by interchanging x and y. So we would have x equals the cube root of 4y plus 8. And our goal at that point is going to be to solve for x, or excuse me, solve for y. So initially, I need to get rid of the cube root. We get rid of the cube root by cubing. So I'm going to cube both sides so that I have x cubed equals 4y plus 8. Again, I'm attempting to solve for y, so I'm going to subtract 8 from either side. So I have x to the third minus 8 equals 4y. I then need to divide both sides by 4, again to isolate the y. So I end up with y equals x to the third minus 8 divided by 4, which represents F inverse. Okay, we're almost done. 23 says the value of y varies directly as the cube of x. Okay, so here again you need to read carefully. It says varies directly. Now, if you have forgotten your formulas, if you go back to the beginning of the midterm practice exam, it's also on the real exam, okay, and you have the formulas for direct variation, inverse variation, and joint variation. Okay, so this one is varies directly, which means I'm going to use the formula y equals kx. That's the generic. But this first statement here actually gives me the formula that I need for this particular problem. I got to translate it from the words to the symbols. So the value of y varies directly as the cube of x. So for this problem, my generic formula is y equals k x to the third. I then need to use the other piece that's given here, and y is 25 when x equals 5 to determine my value for k. Okay, so they give me an initial relationship, and I'm going to plug and chug into that to find my k, my kind of my constant of variation. So it says y is 25 when x is 5. So I would have 25 equals k times 5 cubed. Okay, 5 cubed is 125. So I've got 25 equals k times 125, and then I'm going to divide both sides by the 125. So k equals 1/5. So in its non-generic form, my equation is y equals 1/5 times x to the third. And then I'm going to use that specific formula to figure out the rest, because the specific formula for the rest says what is y when x is 10. So I'm looking for y at that point. So I'm going to substitute y equals 1/5 times 10 cubed. Okay, so I have 1/5 times 10 cubed is 1,000, and 1/5 of that is 200. So my ultimate answer is y equals 200. Okay, but guys, here again, it's a process. It's a step-by-step process. Okay, 24 says the area of a triangle varies jointly with the length and the base, with the length of the base and height. And again, so it gives you initially that relationship. It does say varies jointly, which gives you the clue as to which generic formula you want to use. So we're going to use y equals k times x z, which actually in this problem you've got a's, b's, and h's. It's okay. That's the generic formula. Okay, so for us it would be the area of a triangle varies jointly with the base and the height. And then the second sentence here gives us the relationship so that we're able to figure out the constant for k. So we're going to substitute. The value of A is 24 when B is 6 and H is 8. Okay, so we have 24 equals K times 48. I'm going to divide both sides by 48. So I have 1/2 equals K. So in its non-generic form, we have Y, or let's do it in terms of the A and the B for you. Okay, we have A equals 1/2 times B times H. And then we use this last sentence to figure out the final answer. Okay, so we have, what is the value of A when B is 8 and H is 12? So I have A equals 1/2 times 8 times 12 is 96, and half of 96 is 48. And that will be your final answer. But guys, remember, it's a process. It's a step-by-step process. Okay, last one. The number of hours needed to complete a trip varies inversely with the driving speed. A trip can be completed in 5 hours at a speed of 60 miles per hour. How many hours would it take to complete a trip at a speed of 75 miles per hour? So again, you got to kind of think through this. It tells you that it varies inversely, and generically you would have y equals k divided by x. But remember, this first sentence gives us the generic relationship. Okay, so it says the number of hours, h, varies inversely with the driving speed, d. So it's going to be k over d. And then again, at that point, you've got to figure that constant of variation, which you can find using the information in the second sentence. Okay, so we would have a trip can be completed in 5 hours at a speed of 60 miles per hour. So my speed was 60. and I want to solve that equation for k. So I'm going to multiply by 60 on each side. So I have 300 equals k, which leads me to my non-generic formula that the hours equals 300 divided by d. But I'm still not finished because I got to figure out what it is for this problem. It says how many hours would it take to complete a trip going 75 miles per hour. So we have h equals 300 divided by 75 miles per hour, which gives us 4. So it would take us 4 hours to finish the trip if we were driving 75 miles per hour.